is 6, 7, the distance formula. So the distance formula applies when we're given 2 points on a coordinate plane the distance between the 2 points can be calculated by square root sorry, I hate this formula, so I have to think about it. Yes. Give me 5 minutes. Okay. So what this is, it's a version of the Pythagorean theorem. It's messed around with as the Pythagorean theorem. And I'm giving you the distance formula. I hope it's right. If it's not right, we'll fix it here in just a minute. And the reason it wouldn't be right is because it's one that I never use, so I always have to kind of like pull it out of my memory banks. I apologize. I probably should have looked it up before we started this, but that's okay. I think we're right there. And if not, I'll show you actually the way that I do this, because this is to me, this is kind of a mess. There's an easier way. So let's say I have a point at 2, 1, and I have another point at -2, -2. Okay? And I want to find the distance between these points. How long is the line between those 2 points? So I've got this point, I've got this point. Let's call this x sub 1, y sub 1, and this x sub 2, y sub 2.
Will it, like, x sub 1 and y sub 1 always be like the -1?
No, this is just a way of labeling. It's a good question. Basically, I'm calling this point 1 and this one point 2, but if you called this one point 2 and that one point 1, we'd get the same answer. So yeah, good question. That's not important. So I'm just inadvertently naming those. So if I put these values in here, I'm going to go, let's see, x sub 2 is 2 minus a -2, quantity squared, plus, bless you, 1 minus a -2, quantity squared. I'm going to take the square root of that whole thing. So what I have is, this becomes 2 plus 2, which is 4. And 1 plus 2 is 3 squared, right? Everybody okay with where I'm going with that? 4 squared is 16 plus 9. And if I keep working this down, I get the square root of 25, which is 5, right? So the distance here is 5. By the way, that formula is correct. Now, that's the algebraic way to do it. I prefer a much more visual way. So what if instead of using all these x1s, y1s, and all that stuff, what if I just drew a sloped triangle? What if I drew a sloped triangle? I've got a 90-degree angle here. What's the length of this side of that triangle? One, 2, 3, 4. Yeah, 4? Right. So I've got a 4 here. How about the height? Yeah, it's 3. It's from going from -2 to 1. It's 3. And if I have a triangle with a leg of 3 and a leg of 4, the hypotenuse has got to be, it's got to be 5, right? It's a 3, 4, 5 that I drew. Okay? This is a far easier way. Now, we know a shortcut, right, if it's a 3, 4, 5, but basically what I'm suggesting here is instead of doing all this, draw the slope triangle and say 4 squared plus 3 squared equals c squared, and use the Pythagorean theorem. 4 squared is 16, plus 3 squared is 9. 25 equals c squared, and there's our square root of both of those. I think it's far simpler to make the sloped triangle. That's my opinion. Now, that requires you to have a graph. Can you make the sloped triangle without the graph? And the answer to that is yes. Because what is the sloped triangle? It's rise over run, right? Yeah? So let's take another pair of, well, no, let's take these points. Since we're already familiar with them, we know what they are. So let's say I just give you a pair of points, and I say those points are -2, 2, -2, -2, and 2, 1. What numbers in the slope does the rise come from? The x's or the y's? The y's, right. And what does the run come from? The x's. So here's how I like to do this. If I just have the points so I don't have to graph it, I'm going to look at the y's first. I showed you this a while ago for finding slope, did I not? -2 to 1. How much do you have to travel to go from -2 to 1? 3, exactly. And how much do you have to travel on a number line to go from -2 to +2? There's the two sides of your triangle. 3 squared plus 4 squared equals c squared. Now, I want you to know that there is a formula for this. And I want you to know that it is directly created from the Pythagorean theorem. But I also want you to know that me as a teacher and me as a math student, I pretty much refuse to use that. Not that it's bad or it doesn't work, I just think there's an easier way. So if you can keep your rise and your run, your slope, if you can find your slope, then you can find the distance between those points. Let's look at one more. let's look at one and do it my way. Somebody give me a value between negative 10 and 10? 5. Okay. And?
I was going to say 5. 6.
6. Okay. So there's our first point. And somebody else give me a number between negative 10. Olivia. Negative 2. And? 7. All right. Okay. How much traveling has to occur to go from 6 to 7? 1, right. And how much traveling has to go from 5 to negative 2?
7.
That's true. It is negative 7. Although, what's going to happen to that negative when we square it? Right, it goes away. It's going to become a positive. So now here's what I do. I take the 1 that I got from the y's. So the slope would be 1 over negative 7. But I take the 1 and I square it. And I take the negative 7 and I square it. And that is going to equal the length of the third side of the triangle, the long leg. We'll draw it out here in just a minute so I can prove it to you. But 1 squared, negative 7 squared, 49, good. And if I add those together, I get 50 equals c squared. All right, next step, take the square root. So c equals, I'm just going to say the square root of 50, which is a little bit more than 7. It's just a shade more than 7. Maybe 7, it might not even be 7.1, but it's a little bit longer. Let's graph that real quick. 1, 2, 3, 4, 5, 6, 7. I'll go 7 in each direction. So my first point was 5 and 6. So 5 and 6 right here. And the other point was negative 2 and 7. I want to find the distance between these points. So my slope triangle is going to be this, which is a height of 1 and a width of 7. Can distance be negative? Why? You don't know? You don't say like we go positive 90 miles to McCall or negative 12 miles to CUNA, right? We don't do that. We don't do that with distance, right? We give direction, but we don't call distance negative or positive. So if you end up with a negative like we did, you can either drop it out and just call it 7, or when you square it, make sure that you square the negative and it'll drop out there with the mathematics. Okay. All right. Let's look at one on the page and then I'm going to set you guys loose. Ooh. Let's look at number 14. So this is actually asking for slope. And we have a formula for slope. But I like my method better. Maybe you do as well. I'm going to go from the y's first. From negative 1 to 7. 8. Good. And that's in a positive direction. That's going up. So my slope is 8 over from 7 to 11. 4. Good. And can we simplify that? That's just 2 or 2 over 1, right? Now, for distance, though, I can't use these numbers. I have to use the unsimplified numbers. So use the unsimplified amount, the 8/4. So my distance then is going to be 8 squared plus 4 squared equals the hypotenuse, c squared. It's always going to be c in this case. Sorry, move that over just a bit. So 8 squared, who knows what 8 squared is? 64, good. And 4 squared? So 64 plus 16 is 80. And now I take the square root. It's going to be just a shade under 9. Is it 9.9 something? I'm sorry, shade under 9. I said, yeah, 8.9 something. Okay, so it's about 8.9. There we go. That's the distance between those two. What's the true distance? Square root of 80. Yeah, if it asks for the exact number, it would be the square root of 80. This is an approximation. So not too bad, right? So what do you like better? I'm just curious. Did I do a pretty good job of not selling you on this? Okay. Because I think there's a far easier way. All right, I'll let you guys give that a go, and I'll take roll and come around and hand